Second part of section 5.4 deals with radical inequalities. The first part deals with radical equations. The second part deals with radical inequalities. Solving radical inequalities is really about the same thing or same method or same steps as solving radical equations. The only difference is this last step here. Consider possible values of radicals. And that shouldn't say radicals. That should actually say radicands. R-A-D-I-C-A-N-D. Consider possible values of the radicand. The radicand, if you don't know, is the number or the information under the square root. So the radicand is what's under the square root. Okay, so the steps are pretty much the same. Step number 1, isolate the radical. Step number 2, eliminate the radical and solve. And then step number 3 is the new one. Consider the possible values of the radicand. So let's jump right into an example here. Number 1, 3 times the square root of x minus 1 is less than or equal to 12. The radical is not by itself, so we need to do that first. Let's get rid of that by dividing both sides by 3. Okay, so let me slide this up. The 3's will cancel out, so I'm left with the square root of x minus 1 less than or equal to 12 divided by 3, that is 4. Okay, so once we've got the radical by itself, then we need to go ahead and get rid of the radical. We're going to get rid of it by squaring both sides. If it was a cube root, we would cube both sides. Fourth root would be fourth power to both sides, so on. Okay, so with square root, we're going to square both sides. The square root cancel each other out. We're left with x minus 1 less than or equal to 4 squared. That is 16. Okay, now we need to continue to solve. We need to get x by itself, so we're going to go plus 1 on both sides, plus 1. X is less than or equal to 17. So we have solved our inequality. Now, the new part to this section is the last step. Consider the possible values of the radicand. So the radicand in this case is x minus 1. And I'm actually going to write this in purple. Whoops, that's supposed to be a scroll. Okay, so the radicand in this example is x minus 1. Okay, and since we're talking the square root of x minus 1, the radicand can't be less than 0. Can't be less than 0. Okay, because if it was less than 0, then we're taking the square root of a negative number, and then it's not going to work. So the radicand, the number underneath the square root, whatever we substitute in for x, has to be greater than or equal to 0. Okay, so what this is really saying is that x minus 1, the radicand, has to be bigger than or equal to 0. It could be equal to 0. We can take the square root of 0, but it can't be less than 0. We can't take the square root of negative 1. We know that that's I, but that's not a real number. We're looking for real answers here. Okay, so we actually have a second inequality hidden to solve, so plus 1 on both sides. This tells me that x is greater than or equal to 1. So we actually have two pieces to this solution, or this inequality. Okay, so we have x is less than or equal to 17, but we also have this second part where x is greater than or equal to 1. Okay, so if we've kind of really narrowed our possible solutions. Okay, so our final answer here, we can write it one of two ways. We can say x is greater than or equal to 1, and x is less than or equal to 17, because that's saying that we're greater than 1, less than 17 between those two numbers. Or if you want to use the shorthand, you could go 1 less than or equal to x less than or equal to 17. Either one of those would be preferred. Okay, preferably, if I had to make a choice, I would go with the brown one, this one right here. But if you wrote the one in yellow, this one, that's fine. You would receive full credit on any assessment. Let's try another example. So I'm going to scroll all the way back up. So we got 2 square root of x minus 3 is greater than or equal to positive 3. Okay, so step number 1 is to get the radical by itself. We actually have 2 steps to do before the radical is by itself. So we're going to add 3 first, so plus 3 on both sides. So that leaves me 2 square root of x greater than or equal to 6. Then I'm going to divide both sides by 2. 2's will cancel. We're left with the square root of x is greater than or equal to 3. So the radical is by itself. Now go ahead and get rid of the radical. We're going to do that by squaring both sides. Okay, so square root and square cancel out. We're left with x greater than or equal to 3 squared is 9. So we don't actually have a second step or another step to get the variable by itself, because we've already got it by itself. It was just the square root of x. Okay, so we've solved it. Now consider possible values of the radicand. Step number 3. This one I'm going to argue that we don't need to worry about it, because keeping with this thought, the radicand can't be less than 0, but it says x, the smallest x we can have is 9. There's no way that this could be a negative number. So really, we don't have any second step to do. This right here, x greater than or equal to 9, is going to be your answer. Okay? There's no way that whatever x value, whatever solution we pick would make this square root of x a negative, or the x a negative number, because this says that x is greater than or equal to 9. The smallest answer you could possibly have is 9, and everything above it, but that's not going to include any negatives. So we don't actually need to do step 3, and we kind of did, but there's no going to be, or in this example, there's not going to be this second part where we have to, make it greater than or equal to 0, because the answer, the solution we have, says that x has to be bigger than or equal to 9. It can't be any smaller than that. So there's no way that could be a negative number. Let's try one more here. We got 4 times the cube root of x plus 1 is less than 8. Okay, so the steps remain the same. Get the variable get the radical by itself, and we've only got one step to do here. Going to divide both sides by 4. Okay, so we'll have the cube root of x plus 1 is less than 8 divided by 4. That would be 2. Okay, once we get the radical by itself, we need to get rid of it. This time we've got a cube root, so we're going to cube both sides. Going to raise it to the 3rd power. And what that will do is that will take away the cube root, the cube, so that leaves me with x plus 1 less than 2 to the 3rd power. That would be 8. Okay, so we haven't solved it yet. We got to get x by itself. Okay, so I'm going to subtract 1 from both sides. Okay, so that leaves me with x less than 7. Now, we need to do that step 3. Consider the possible values of the radicand, the numbers underneath the radical. This time, we're using an odd radical. We can have the cube root of negative 8. We can take the cube root of negative 1. We can have negative numbers underneath an odd radical. So really, we don't need to do any limiting to our answer, because with cube roots or with any odd roots, you can have a negative number underneath your radical, because we can take the cube root of negative 8. That's a real number. It's negative 2. The cube root of negative 1 is negative 1. Okay, we have real answers when we have when we take an odd radical of a negative number. Okay, so your final answer is just this. X is less than 7, because we can have negative numbers under here. We don't need to do any limiting where it's got to be greater than or equal to 0, because we can have negative numbers underneath odd radicals. With even radicals, like the first example, if we're talking less than, then we're probably going to have to do some limiting. Okay, the radicand can't be less than 0 when we're talking even radicals. Okay, so square roots, 4th roots, 6th roots, whatever. Okay, the radicand can't be less than 0. So if you have something like x is less than or equal to 17 with an even radical, like this one right here, then you're probably going to need to do some limiting where you set the radicand greater than or equal to 0. Okay, if you have an even radical but it's greater than a specific number, probably you're going to be okay with that answer. Now, let's just say, this is going to be kind of a side note here. I'm going to switch to brown. Let's just say, and this is not part of the answer, let's just say our answer was x is greater than negative 2. Well, that's going to have to do some changing, because we can't have a negative number underneath this. So actually what our final answer would be, when we bring this down, it would actually have to be x is greater than or equal to 0. Okay? And this is not a smiley face, that's an arrow, by the way. So just keep that in mind. Usually if you've got x is greater than with an even radical, you're going to be okay with that solution. If you have x is less than with a even radical, then you're probably going to have to do some limiting. If you have an odd radical like this one, chances are you're probably, or not chances are, you're going to be fine with whatever answer you get, because you can take a positive number, take the 3rd root. You can take a negative number and take the 3rd root. It works either way. So with an odd radical, you're fine with your solution. With an even radical, you might need to be a little more aware of what your answers are, and you might need to do some limiting like we did in example number 1.